Okay, my name is Muhammad Zulhazwan bin Bakar. My matrix number EDE180-185. So I will explain the result from the task 1. Okay, so I will explain the result for this task 1. So the result is this. We get this, and we need the value of Emax for each gaps. So the Emax we put in this table, tabulate this and calculate the Emax calculation, and this is a percentage error and field utilization factor. So from the value of this Emax simulation, we compare with the gap this. We will draw the graph. So we can see the Emax, when the Emax is increased, when the gap distance is increased, Emax will be decreased. So you can see it is inversely proportional. So after that, we compare the Emax simulation with the calculation. You can see this is not difference with each other. You can see when the value of the gap distance increase, the Emax simulation will be same, and the percentage error of the Emax simulation and calculation, we can see from 0.1 meter to 0.04 it decrease, and after 0.04 it will slightly decrease till 0.175 meter. And then this is a field utilization factor. Okay, we can see it decreased till 0.175 meter. The Emax calculation we use from this formula and put it on the Excel. So that's all.
Hello, my name is Ibrahim Zabdul Wahab. My matrix number is DE1X0169. I will discuss about task 1, shape 2. Alright, there is the shape spare electrode using software FEEM, where one of the shape is 180 degree and another one is square with the gap distance. Okay, there were different color as can be seen, which is have different value of electric field intensity at the gap area. At the very high gap area, the electric field intensity of the electrical field can be seen. Alright, the result have been recorded. That is, we can see that the value of electric field intensity of simulation and manual measurement were decreased when air gap distance is increased. Next, the percentage of error between the simulation and the manual calculation also increased as the gap area distance increased. Alright, from the value has been recorded, we can get the graph of maximum electrical field Emax for each gap distance. From the graph, we can see the value maximum electric field Emax is inversely proportional when the gap distance is increased. The form of the graph is same as peer gap, but the value is not same. This is because the shape of the electrode is not same. When the gap is increased, the value become more different from calculation value. That's all. Thank you.
Okay, for FEMM lab 2, we will have to construct a C core and I core to identify the magnetic properties of the core. Okay, this is the C core and I core that we managed to construct. Okay, so we are supposed to plot and get the value for the flux density, the field intensity and current density. So after changing the value of current for 25, 50, 75 and 100, and after we plot the graph of current density versus current versus flux density, okay, we can see that the flux density increases as we increase the value of the current. Okay, so we can see here that the flux density is directly proportional to the value of the current. So if the current increase, the flux density also increases. Okay, so it is the same for the field intensity and current density. As we can see here, for the C shape, the value of the field intensity and current density increases as the current increases. So the field intensity and current density also is directly proportional to the value of flux density and current.
Hello and good day to Dr. Cook. So today I'm going to present about the U-core shape for this simulation. So as we can see, the shape is changed from C to U shape. And for the coil, we will use 50 ampere, and we will try to simulate it. Okay, so here are the result obtained after we simulate. So we can observe the result for flux density, field intensity and also current intensity for the U-shaped core. And we will change the coil to 25 ampere, 75 and 100 ampere. And here are the result obtained when we change the current for the U-shaped core. Okay, so when we change the shape from the C shape to U shape core, we can observe that the flux density, the value of flux density will slightly decrease, and for this we can say that curve edge C core have more evenly distributed and lower flux density compared to the U shape core. The field intensity also decreases slightly, while the current density remains the same even when changing to the U shape. So overall, when we increase the current from 25 until 100 ampere, we can observe that all the flux density, the field intensity and also the current density will also increase. Okay, that's all from me. Thank you.